today's lesson, we're talking about the start of Chapter 5, Section 5.1, where we'll discuss the unit circle. Now, we've already kind of done some topics on the unit circle with our discussions in Chapter 6. But here now, instead of being in degrees, we're going to be more in radians. Now, it works exactly the same way, except instead of going on the inside of your circle like we would for degrees, that's why we use the variable theta. Now we'll use the variable t to reference the radians. Now radians are going to be in pi or in just decimal form or number point decimal form. So remember also that because of we're being on the unit circle, if I need to find anything like sine and cosine, we can use the relationship of x squared plus y squared equals 1. X, remember, is representative of cosine of x, and y is representative of sine of x, or your angle, I should say. So let's erase the x. This kind of represents the angle t. Okay, so that squared equals 1 as well. Okay, so there are two vocab words that we'll talk about: terminal point and reference number. Terminal point is the point on the unit circle that represents any given value of t. So meaning when I draw this angle of t on this sample one for general, this point that occurs is called my terminal point. So that gives me a value, so cosine of t, comma sine of t, and then that is how we find the terminal point. So like if I have the measurement of, let's put it in degrees for you, so like say 135 degrees, the terminal point for that is negative square root of 2 over 2, comma square root of 2 over 2. But now we'll use the 135 degrees in radians, so it'll be 3 pi over 4. The next vocab word is reference number. This is the same as a reference angle, except it's in radians. So they use, instead of an angle, a number, because a t value is actually more so a number than an angle. And remember, all reference numbers are in the first quadrant. So anytime we find something, we'll find it in between 0 and pi over 2, or 0 and 90 degrees, which it used to be in. Okay. Now remember that when we're finding reference angles, we had certain values that we subtracted to get into certain quadrants. So in the first quadrant, we'd stay the same. Second quadrant is pi minus t, so it's like 180 minus t. The third quadrant, we will take our reference, or our number, or like our angle, I guess, and take it minus pi. So it's like our theta minus 180. And then 2 pi minus t for the fourth quadrant, which is the same thing as 360 minus our theta. Okay? So that's what we need to know for this section. So moving on to the first slide. Example 1 says find the terminal point of the following. So if I'm giving you a t value of 3 pi, and I want to know the terminal point, remember, use your unit circle. So once around my circle is 2 pi, so that another pi gets me over here to this point, which is the point negative 1, 0. So then that is the terminal point. So they want both values, the x and the y, since they're not giving you a specific trig function that goes with it. T value, when it's negative pi over 4, is if I'm going around the circle and I go in a negative direction, so that'll be in the fourth quadrant. That's the same thing if I went all the way around the circle to that same point, so a positive value, so same t, or terminal point for the t. So this point, since it's negative pi over 4, is the same thing as 7 pi over 4, which in degrees, that would be the same thing as 315. So that terminal point should be square root of 2 over 2, comma negative square root of 2 over 2. So remember, cosine is, or x is positive in the fourth, and y is negative in the fourth. And then for c, we have 3 pi over 4. That would be in the third quadrant because we are greater than pi over 2 but less than pi. So my terminal point for that one would be the negative square root of 2 over 2, comma square root of 2 over 2. Okay? So those would be our answers for those particular problems. Now if we try to find the reference number of a certain t or angle measurement in radians, so let's say we have 7 pi over 4. So first you need to locate where that is. So here on the unit circle, if I say something is 7 pi over 4, so I go all the way around to here, that's pi. To there, it's 3 pi over 2. If I went all the way, it would be the same thing as 2 pi, or 8 pi over 4. So it's got to be somewhere in the fourth quadrant. So then I need to apply 2 pi minus t. So 2 pi minus 7 pi over 4. We make common denominators. So 8 pi over 4 minus 7 pi over 4 gives me pi over 4. Then letter B. Now sometimes your values are not on the unit circle, which is fine, or the unit circle in which the values we have memorized, but it still doesn't make it impossible to find your reference number. We just still have to figure out where it is and then apply the particular thing to get our correct reference number. Okay, I mean the particular operation. So if I have 8 pi over 7, well that's more than pi, which is 7 over 7. So that means it just creeps into the third quadrant. So that means I need to take t minus pi. So in this case my t is 8 pi over 7 minus pi. Make common denominators, so it would be 7 over 7. So 8 pi over 7 minus 7 pi over 7 gives me pi over 7. And that is my reference number. Notice how it's in between 0 and pi over 2, just like pi over 4 was. Now here, sometimes your stuff is not radians, which is okay. You still apply it the same way. You just have to think about your radian measurements differently instead of in terms of pi. You have to go by the decimal value for each. So let's say for our unit circle, you're starting at 0. Pi is 3.14. And remember that 0, same thing as 2 pi, which is 6.28. Okay, so here, if I wanted to know what pi over 2 was, approximate it, so that gives me about 1.57. And if I wanted to know what 3 pi over 2 is, it would be 4.71. So if I'm looking at a number value, then that's easy for me to see because 5.8 is greater than 4.71 but less than 6.28, so it falls in the fourth. So here I would use, just like I did for A, 2 pi minus t. So 2 pi minus 5.8. Now here we can't use any common denominators based on how it's written, so I just take 2 times pi minus 5.8, and that gives me the decimal answer of 0.48, which, if you go back to the values we wrote down, that's in between 0 and 1.57, so then that meets the criteria of being a reference number. Okay? Have fun.